So actually at this point, I guess I'm more or less a figurehead here. We've reached a point, oh, thank you. At this point, John had mentioned there's a very interesting loop that's formed at the MOC and NERC, and I think we're an example of that. And I'm sort of on the tail end and stepping out, and the real folks that are responsible for what you're about to hear about is really Danny, Isaiah, and Dylan, and Heidi, who have actually taken the next stage of showing that we can actually scale education on the MOC. The OPE project was actually just a harebrained way for me to try to get people to help me to scale the building of the education of a low-level systems class on scalable resources in containers using open source materials so that we could demonstrate that actually real education can happen out of best-of-breed tools. But what we've ended up doing is evolving that further into, now at this point, we're going to present to you a little bit about an architecture that we evolved this idea of doing open source education out from just my class or the class that Aran was doing into an SDK and a toolkit that would allow people to get the construction of a container and textbook material, have some help with that. So that was one aspect that the project has evolved to. But then the second aspect that a lot of focus has gone on this year is to demonstrate that we don't need to use AWS. We can actually put this last layer that we were after, which is an open data center on an open cloud. Up until this year, everything we were doing was on AWS. But now we've actually reached the point that we have hundreds of students taking classes on the infrastructure in the NERC, and that's really been powerful for us. It gives us much more freedom and control. Okay, so I'm just going to briefly tell you a little bit about from the OPE, so this idea of how do we construct or encourage educational material being built in open source tooling, but not being toy. How can we actually build educational material that can let low-level systems classes to happen? So what we've evolved to is an idea of an SDK model. So this is kind of a big, complicated diagram, but the most important thing is that the Red Hat team has taken our sort of seed ideas and turned it into an SDK with a command line tool and a whole bunch of underlying repositories that allow you to very quickly bootstrap a new course, where a new course is composed of stuff to build textbooks, but these days also to build containers that contain all the software required to run your class, such that these containers can then be input to the NERC, for example, but also that it seeds you and encourages you that all the material you build ends up being repository controlled. So you can build a community around your class, and that has nothing really to do with OPE, right? In an open source way, we don't require lock-in. However, on the top half of this side of the diagram, we also encourage folks to help us build that SDK and evolve it. Okay, so now I'm going to hand it over to Danny to tell you about what's actually possible now on both of these fronts.
So the first thing possible is we are able to construct a course with books and containers. So OPE tools standardize and ease the construction of core elements of the materials. This includes not only just books such as textbooks, lab manuals, but also the environment where students engage with these materials, that is, containers. The process is quite straightforward. To construct a book, you can simply run the command OPE new book, and this will create a new Jupyter notebook for you. With the support from Jupyter Notebook ecosystems, authors are provided with templates and examples. They can now add and modify contents to their book. Once the contents is ready, OPE build command compiles all of the chapters and renders them into accessible formats such as HTML. Then the last step is OPE Pub. It makes your book published to the web via GitHub page. So now let's explore how an educator can construct his customized containers. You don't actually have to create a container from scratch. OPE tools have already prepared that for you. So you can simply run the command OPE new container to create a container. Then you can add course customized softwares, package, and dependencies in your container. OPE build command compiles all of the customizations, and you can now push the container to a registry such as KIO. Now it's time to deploy your container. You can either choose to deploy it on a cluster such as NERC OpenShift, or you can spin up locally. It's your choice. Authenticated students can now get access to their containers via web browser or run it locally. So yeah, here is a quick glimpse of the current CLI tool, the functionalities that it has. And if you would like to dive deeper into the CLI tool, we've already prepared a user guide for you to get started. So our next topic is OPE on NERC. Professor Appavoo will share his insights into the success stories of courses using OPE on NERC.
Great, so the second aspect of what we focused on then is now independently, how do you, independent of OPE, how can you use the NERC to run your class? Now in truth in advertising, some of the folks who've been running the class this semester, since this is the first semester that it's been running on NERC, I was just chatting with them, and yeah, we've had some problems. As a matter of fact, we had a problem where our users, 150 students, because of a freedom in the front end, created usernames that didn't line up with their BUIDs, and for a bunch of time, students couldn't figure out why they couldn't log in. We had a problem where we had an outage. We had a problem where the staff was not able to use the same amount of storage as they were used to when we had configured it on AWS. So we are definitely running real things. And we are definitely on the path to doing this in a way where we've run those real things with 300, well, actually well over 300 students, and we're resolving the bugs. And if all we've had go wrong is one 12-hour period where we lost the system due to actually a fascinating bug, and then having user IDs unable to match up usernames, no one's complained that the container went away while they were writing their assignments. No one has complained that the system roughly all of a sudden froze. Have they complained about the course material? Of course, so that we must be doing the right thing. Okay, so in this last semester, we've been having our class 210, we've been having ECE, Introduction to Operating Systems, and we've also been having data science classes that don't use the OPE containers, but more broadly access the system. Yeah, I'm not going to pay attention to the sign. So the last thing I just want to really focus on is that the model that the student sees is simply, we're releasing students into a system, they get a container, and they've got a web browser. That's it. Now, Danny will actually tell you how it actually works.
Yeah. I want to highlight the core strengths that set OPE apart. That is, we have the flexibility and the ability to support customized needs. First, let's start with scalability. We've conducted tests on NERC Production Cloud before classes began to make sure that a surge in student accessing containers won't lead to significant delays, and the results were very promising. Initiating 300 notebooks concurrently led to an average latency about 20 seconds per notebook. More importantly, this testing framework is built to adapt to a range of OpenShift clusters, offering flexibilities over a variety of environments. And secondly, it's about cost efficiency. We have implemented a notebook shutdown cron job tailored to instructors' needs. This cron job runs every hour. It kills idle Jupyter notebooks after a preset time, and also remove containers with wrong image or wrong container size that students might have accidentally created them. This is aiming to optimize resource and reduce cost. We are also actively monitor and report our resource utilization to better understand usage patterns. So on the right side of the slide, the first graph shows the weekly resource utilization, and on the 6th day, it changed dramatically. That's the day we officially applied our cron job. And the second graph shows a daily resource utilization following by the starting of the cron job. It offers a clear view of how the cron job helps enhance the efficiency. So I also want to emphasize that these improvements go beyond just scalability or cost efficiency. It's more about making open education and research infrastructure more accessible, sustainable, and efficient. As we move forward, it's exciting to see potential courses and student projects are eager to use OpenShift AI on NERC. They are from data science projects to software engineering courses. With OpenShift AI on NERC, students and researchers can gain access to not only just Jupyter notebooks, but also a variety of advanced features such as AI, machine learning, model serving. So lastly, how do you contribute? So we have experienced students in helping us test and improve OPE. So please come to the discussion group to dive deeper. We also provided additional resources and talks on OPE for you to get started. Thank you, everyone.
One last thing. We were informed to tell you that the barn doors are open. We are encouraging and want classes, and we're ready to do it. So please come and chat with us and tell us about what you'd also like in terms of if you're planning classes.
So I'd like to add two things that weren't stated. First of all, the work was awesome, but it took 15, 20 minutes to spin up 100 machines on AWS last year, 100 containers, then 20 seconds is the average now. So that just shows the difference when you get bursts of students. And the other thing is that last year, we calculated it was about $170 per student term for the kinds of courses we're offering, Jonathan and I, and we estimate the cost this year will be about $20 per student term. And it's now being charged by, like, so BU departments are now paying for it because it's sustainable at $20 per student, whereas 170 was not. So I just wanted to add those 2 points. And thank you for covering the bill last year, Heidi.